Welcome students to another video lecture with Mr. Connect. I'm going to try and apply your feedback that you provided me and keep this as a shorter lesson. So go ahead and pause here and copy down what you see, and make sure when you do copy, you recognize that this does say 1A and 1B. They're both step ones. It depends on whether you have different or same signs. So go ahead and pause here and copy down what you see. All right, welcome back. So our focus in this lesson is when multiplying and dividing integers, how do we find the sign of the product or quotient? So we have how to multiply and divide integers. We have this wonderful heading here. And we'll have a model for 1A and a model for 1B. Notice it's not step 1, step 2. So if you did make that mistake, change it to 1A and 1B. So the first thing is if it is same signs whenever we multiply or divide, our product becomes a positive, or quotient becomes a positive answer. So model for 7a, we have -8 times -2. They're both the same sign, therefore our answer is a positive, and we end up with 16. If the two integers are different signs, then we get a negative product or quotient. So 17, -5, we know we're going to have a negative. I'm going to do some multiplication on the side so I don't make any mistakes. Nice, so we end up with -85 of our solution. So again, it's real simple. Whenever we multiply or divide, if they are same signs, it's a positive number. If you get different signs when you multiply or divide, it's a negative. That's simple. I'm going to jump 2 slides ahead. Please make sure to leave enough space for your own handwriting to complete these problems. So if I'm showing 5 lines, you may need 7 if you know your sizing. But go ahead and pause here and copy down what you see. Okay, welcome back. So really, we're going to continue applying those examples of substitution and everything else. We're just going to start applying it to integers now. So that's the key in most of our courses. Anything we do learn in our past will be recycled and added in as we move forward. It won't be dropped apart. So we need to substitute into our expression. So I like to use those empty parentheses like we're supposed to. Yep. And then we plug our numbers in there. And then if you did have any trouble in our past lessons on the order of operations, this may not be a bad time to study it once again. So our first step is to multiply or divide. We have two negatives, -8 and -3, so we end up with a positive 24. We bring everything else we haven't used down, adding and subtracting. We're adding with same signs. That means we stay a positive, and the answer is 26. All right, moving on, next question here. So question 2 is a great model of what to do when there's more than 2 numbers. So all of our skills only work when we apply 2 numbers at a time. And when we have more than 2 numbers, we do it 1 step at a time and always combine 2 numbers at a time. So when we have -1 times -3, we get a 3. Everything else comes straight down. And then we have 3 times -2. That's going to get us a -6. -6 times 3 is -18. And that's how we do it. We just do it 1 step at a time, 2 numbers at a time. So moving over to example 3a, -72 divided by 9. Well, different signs, so we end up with a negative, and division of 72 by 9 gets us 8. So our answer is -8. Whew, I boxed my answer there. I'm so sorry, students. Let's get that box out of there. Someone will pick on that. Sorry for the bell in the background. Okay, 3b, -6 times -9, both negative. That means our answer is a positive solution. We have 54. Remember, every example we do, you should actually be reading about what to do in the steps as you go forward. I did not do a very good job of modeling that in this video lecture because I'm trying to save time. So remember, you should read each step as we go through it. So I'm actually going to go one more slide ahead before I go for number 5, because the point of example 4 and example 5 is to show the comparison of where the word each shows up in these problems. So if the each shows up in the question versus a part of the problem, it'll change what operation it means to apply, whether it means to multiply or divide. So go ahead and pause here copy down example 5 and 6, leaving enough space to still complete number 4, and then we'll go over it. Awesome. Welcome back, students. So, as I've taught you before, we're going to mark up this text. So, Isabel pumped 20 gallons of water out of. Oh, out of is a very important word here because that's going to signify not a positive number, but a negative number. And this was done over a period of 10 minutes. Okay. At a constant rate. I'm not going to circle constant rate, but if this wasn't constant, everything we're doing wouldn't actually work. All of these things have to be constant to actually be applied. So what was the change? Okay, I got to bracket my question area or focus of the problem. What was the change in the amount of water in the pool each minute? Okay, this each showing up in the question means that we need to actually divide in this problem. They've given us the total, and we need to find out what happened each minute. And it's not that difficult. It's set up from the question from left to right. So it mentions amount of water in pool first. Well, the amount of the water in the pool is 20 gallons. And the each in this case means divide. And minutes, well, the total minutes was 10. How many of you noticed how we still translated the question from left to right? I got to try and clarify that that is the easy way. I've made one mistake. Can you find it? Yeah, it's not using the out of. We need a negative on the 20 since the 20 gallons of water is out of the pool. That's leaving the pool. That's a negative number. So we end up with -2. My circle doesn't like it right there. So -2 gallons per 1 minute. So let's go over to problem 5 now. When we circle this problem, we have Sam added 3 fish, so we know it's a positive, to his pond each day. So what confuses a lot of students is they read add and they don't realize that the each is the operational word here. Added in this case is signifying the positive number. And he did this for 21 days. We're going to bracket our question area. And the key word to know that we're not dividing in this problem but multiplying is one, the each shows up in the problem, not the question. And this question asks for the total. That means we need the large amount that actually happened. So translating this from left to right, we have 3 fish added each day. Remember, the added in this case is multiple or is a positive number. And we did this over 21 days. So 3 fish over 21 days, we have 63 fish per day. That's how much, actually that's not fish per day, that's the total fish. See, even I can make some mistakes. Okay, to prevent this from going too long, I'm going to show you example 7, which is a mean problem, and we're actually going to evaluate the mean in class. Before I actually have you copy that down though, I do need to express there's a synonym for mean. What's the synonym for mean? Yeah, if you said average, it is average. And since I'm not going to have this worked example shown through the video lecture, I do want to remind you to find the average. We put all the numbers, the total of all the numbers on top divided by the number. Hashtag is a symbol for number of numbers. And I will show you how to do that in class. So pause here, copy what you see, make sure to leave 6 and example 7 open for us to do in class, and any questions you might have, make sure you're filling in that question column. Thanks students for your time. I'll see you soon.